Question 19 is a polar graphing question. We have r1 equals cosine theta, r2 equals sine theta, and it says which integral below determines the area of the shaded region. So it already gives us the picture, so we don't need to worry about plotting it in this case. And it gives us this shaded region, which looks like it lies inside of r2 equals sine theta. So remember, r2 equals sine theta is a circle that is shifted along the y-axis, whereas r equals cosine theta is the circle shifted along the x-axis. So if we want to find this area, it looks like the first thing we need to find is we need to find the point of intersection. So I'm going to set these equal to one another. Sine theta equals cosine of theta. Okay, so what I can do is I can divide the cosine over, and I actually end up getting tangent of theta is equal to 1. And that's because sine over cosine is just equal to tangent of theta. So I need to find where tangent of theta is equal to 1. Well, if we're only looking in the first quadrant in this case, theta is equal to pi over 4. So I know that this intersection point is pi over 4. Good. So now, what I need to figure out is what is going to be the definition of my area. So if I'm looking from the intersection point to the end of the first quadrant, I know that that'll be pi over 4 to pi over 2. So that's good. So we have that down at least. But now, so it looks like initially what I can do is if I extend out my radius, I would hit pi over 4, and if I swept along the area of this r2 equals sine theta, it looks like I could probably get that entire shaded area. So the area that I'm actually going to be looking for in this case is r2 squared, which is sine of theta quantity squared d theta. But there's a problem, and that problem is that when I do sweep along there to try to get all that area, I end up getting all this area that I don't want in here. So how do I get rid of that area? Well, it turns out that if I sweep this cosine theta from pi over 4 to pi over 2, I trace the inside of this circle. So what I can do is I can subtract off pi over 4 to pi over 2 of cosine theta quantity squared. By subtracting that off, I subtract off this area inside of here, and I'm only left with the area that exists inside of sine theta. So now what I have is I basically have the area of my sine theta minus the area that's traced by that cosine theta. And if I look at my answers, I see that A matches it perfectly. They both have 1/2 up front, there's a minus sign in front of the cosine, and they're both quantity squared from pi over 4 to pi over 2. So letter A is the final answer.
The Teaching Center, UF's Learning Resource Center.